Hello everyone, my name is Akhona Stafane. I'm going to take you through the Sandy Logistic Challenge where we estimated the delivery time of arrival. The aim is to improve customer experience of on-demand logistics startup Sandy, which is a growing delivery startup with unpredictable delivery times. The aim will be to reduce costs of doing business. The problem statement is as follows: to build a model that predicts the expected time of delivery of orders from the point of driver pickup to the point of arrival at final destination so that customer experience is enhanced. The method followed is a predictive modeling technique. This is the regression problem since the target variable is continuous. The target variable is the time from pickup to arrival. Predictors include distance, temperature, precipitation, and etc. While doing the exploratory data analysis EDA, there were missing variable data. So temperature was missing 20.6% of the data, while precipitation was missing 97%. Which means that temperature was then discarded while precipitation was imputed for model building. I then looked at the distribution of the target variable, and the raw target seems a bit normal. However, it looks skewed to the right, while the log transformation of the variable is skewed to the left. And I also looked at the square root transformation of the variable. It looks more normal than the other variables. However, it has got two peaks. We also looked at the correlation of the explanatory variables, our features, and they look highly correlated, which means that other features will have to be excluded in the model. The models that were built were ordinary squares, OLS, the lasso, ridge, k-nearest neighbors, decision tree, random forest, as well as the stochastic gradient boost. So the ordinary squares model outperformed the rest of the models, excluding the gradient boost, which had the lowest root mean squared error. However, we took the ordinary squares as our final model due to simplicity and to the fact that it is close to the lowest model in terms of the root mean squared error. I then looked at feature selection using regularization, zero and near zero variance feature, and feature correlation as mentioned already. So the aim of regularization is to minimize the sum of squared residuals and a penalty term whereby less important coefficients shrink, and then we will take the coefficients that still have large magnitude as our final variables. So 0 to near zero variance features identify features with little variance and exclude them in the model since they have little explanatory power, whereby feature correlation looks at the correlation of the features and of course exclude features with high correlation, so to avoid multicollinearity in the model. So our model had these four important features: distance, ride ID bins, pickup hour, sign of pickup time. And as we explained, it's the OLS model, so which means that these variables are linearly correlated with the target variable. In this exercise, a prediction model was built to solve a delivery logistics business problem. Interesting insights between the relationship that features have with the target were discovered, 4 to 5 features contribute to the model's predictive performance, including distance, as already mentioned. Thank you.